For this session, we will practice how to visualize network data and save the outputs after conducting analysis. Open NetMiner. Last session, we imported data onto NetMiner and edited the data. We will continue from where we ended last. First, we will do a simple visualization with the data we have. Data visualization is crucial for analysis. It is commonly used to understand the current state of the data and to intuitively look at the structure of the data. On NetMiner, you should select the Visualize menu. Here, if you go to the Spring menu, you can see that there is an option for 2D or 3D. Let's do a simple 2D visualization. The reason why there are so many Visualize menu options is because there are various visualization algorithms that we can use. In this session, we will learn how to create the basic network graphs. First, go to Visualize, then Spring and 2D. From the results, we can see the nodes, that is, the company employees. The output shows the employee IDs with the node entities represented with a red circle. On the screen, the nodes are spread out with lines between them. These lines are links. However, the current screen did not run the visualization layout that we want, but it's just a random distribution of the nodes. On the right is the panel, where we can control different data visualization options. On the top of the panel, you can select the network data to visualize. Since we only have one network data currently, only one network is presented. If there are lots of network data together, you can select the networks to visualize by clicking on the checkbox. Let's have a look below. The Spring map is where a line is attached between two nodes like springs and act as if springs are stretching on each other. There are many other layout algorithms besides this as well. The algorithm that we saw on the menu before can be selected on the Node Layout Algorithm combo box. The Kamada and Kawai algorithm that is already selected is the most basic layout that is used when drawing a network. If you scroll down on the panel, you can see the Run Layout button. By clicking this button, you can run the visualization which follows the Kamada and Kawai algorithm rules. The feature of this map is that it structures the network data very neatly. You can think of it as a picture where the nodes do not overlap, and a spring is attached and pulls the nodes. Using these simple visualization tools can help briefly identify where there are many links and which nodes are isolated. Also, the small icons on the top are buttons you can manipulate while viewing the visualization results. The Run Process button is also here as an icon. If you click on the button, a new drawing is created. This button changes the size of the nodes. Then, there is the node and link styling icon, which looks like a palette. It can add color or change the shape of the node and links. You can use this feature when you want to attach the network graph to a report or when you want to better express your analysis results. Now, we can try adding color to the nodes based on their gender. Click on the palette icon. You can use this window to style both nodes and links by clicking on the tabs on the top here. In the Node Attribute Style tab, we will use the color function, which can change the color of the nodes based on their attributes in the data. Click on the combo box, which has the node attributes listed, and select on gender to apply color based on this attribute type. In the preview area below, you can see that the color for male and female are automatically assigned. As we created a new node in the previous session and did not add an attribute to it, we can also see a missing value node in blue. Click on the Apply button to apply the colors to the network graph. Next is link styling. Typically, a link may or may not have a weight. The practice data we are currently using does have weight values, which are usually represented as different line thicknesses based on the weight. Let's try doing this now. On the Node and Link Attribute Styling window, select the Link Attribute Styling tab. Select the Width tab next to the Color tab underneath. Since the only link attribute in the data is the weight, you can leave it as it is. If you see the preview below, you can see how the thickness of the links will change. Click Apply. Now you can see in the back how the lines of the links in the network map have changed. You can close the styling window now. So, this is a simple way to get data from NetMiner and visualize it right away as a network map. The steps we just went through was for a one-mode network. Now, let's see how we can visualize a two-mode network. From the Visualize menu, at the way bottom, you can see the two-mode menu. The two-mode menu also has the Spring menu. If you click on the Spring option, since there is only one two-mode network data, the data you will visualize is already selected. So, you can just press the Run Process button on the right bottom of the screen. The two-mode network styling is already assigned. The main node is in red and subnode is in blue. Like this, you can do a basic data visualization for a two-mode networks as well. Now, we will run a simple analysis and practice utilizing the results. So let's first try a simple analysis. One of the most basic network analysis methods is a degree analysis. The degree value for each node is the number of neighboring nodes or number of links the node has. Hence, it is a basic measurement which shows how many links each node has. We will run a degree analysis by first going to the Analyze menu. In the Neighbor menu below, you can see the degree analysis on the top. When you click on this menu, you can see a window on the right showing various options. Since there is only one data, the input is already selected. Click Run Process on the bottom, and you can see the analysis results as a report format. On the bottom of the report, you can also see what ways the report can be represented. The structure of this tab can depend on the type of analysis you conducted in the Analysis menu. A table with the results is also provided based on the analysis. There are 4 types of reports you can get from a degree analysis. The first report with the statistics table is the main report. The second tab, starting with a T, is a report in a table format. The third tab, starting with a M, is a map report, which is the same as a network map. Let's first have a look at the degree table. It tells us the number of degrees for each node. If we go to the network map on the last tab, we can see how this degree analysis result is visualized as a network map. Now, I will show you some convenient functions of a degree table. Due to the direction of the data, degree analysis results are shown in two columns, in degree and out degree. For example, the current node adds 7 attributes, but you can add an in-degree value to use in a statistical analysis or data visualization. To do so, rather than saving the table with the in-degree value as a separate file, you can just right-click your mouse and click Add to Work File, Node Attribute. When the Select Attribute window appears, you can select one of the two columns. Select the in-degree to add it to the node attributes and press OK. The successfully added message should appear like this. Where would this selected column be added to? If you click on the main node set, you can see that the analyzed results is added to the dataset. You can even visualize this added analysis outcome by changing the size of the nodes or its color. Adding analysis results like this to the main node set is a function you should always be aware of, as it is used very often and efficiently. Another very convenient function I will introduce is exporting the table results you see here as an Excel file. If you right-click your mouse from the main node set table, you can see the Open in Excel menu. If you click this button, the table you see on the screen opens as an Excel file. Let's try this now. As you can see, an identical table is shown on Excel. You can use this function not only for node attributes, but also for link sets. That is, one-mode network. The Open in Excel menu by right-clicking on your mouse is also in the link set. Similar to the Open in Excel function is copy and pasting the table yourself. Let's try copy and pasting this link set to the Excel file. You can select all the data by clicking on the empty space on the left of the first column. Now, click on Ctrl+C and open an Excel file. Create a new sheet on Excel and Ctrl+V to see the link set data you saw earlier pasted on Excel. So far, we have completed data visualization, analysis, and practice functions that you may use often with data analysis results. Now, let's save the NMF file. When you complete an analysis and using different functions for editing, you should save the project file somewhere. Go to the File menu, click Save to locate where you would like to save the file. I will save it in my desktop. Name the file Sample Analysis and save it as an NMF file. The Set Password window that appears afterwards is where you can set a password for the file you are saving. The top section of the window is setting a password in NetMiner, while the bottom section is setting a password in NetMiner Viewer. NetMiner Viewer is a software where you can only see the analysis results, but support for the software has stopped. It is currently unavailable. Hence, leave the password for View as public and enter a password for the NetMiner project file only. If you click on the combo box for the Save option and select Private, you can enter a password. For now, I will save the file as public without a password. Click OK, and now the file is saved as where you designated it in your PC. If we have a look and check the desktop settings, you can see that the NetMiner file with the correctly saved name is there. Now that we have saved the file, we have completed practicing how to visualize analysis results and save the project file. Next time, we will practice how to add a save script format to NetMiner. That is, add an extension function as a separate menu on NetMiner. Thank you.